Hello everyone, again this is your junior high school math teacher, and I'm going to discuss the last two uh, graphs of uh, the functions cosecant and secant. After watching the video, you should be able to determine the different properties and the behavior of the graph of uh, circular functions, particularly secant and cosecant functions. And you should be able also to draw the graph of these functions. Okay? Now let us consider the graph of cosecant function. Let us consider the properties and the illustration. Now for the graph of f of x equals cosecant of x, so the period is equal to 2 pi. The asymptotes occur at the x coordinate determined by this formula. X coordinate, okay. The asymptote occurs at the asymptotes occur at some coordinates along the x-axis, and these coordinates can be determined by this formula: x is equal to n pi, where n is an integer. The graph is symmetric with respect to the origin. And for the fourth property, the cosecant function is an odd. Again, the reason the function is an odd, because if we replace x by negative x, the value of the cosecant function will be changed from positive to negative. Okay, how about the graph of cosecant function, wherein the coefficients are not just 1 but any other value? Okay. Now we have the graph. And the properties are, okay, for the given function, the period can be determined by the formula 2 pi over b. And again, b is taken from the coefficient of x. And the asymptotes of this function happened at x coordinates, and these coordinates can be determined by this formula: x equals np over 2, where n is an integer. Okay? Now let us have some examples about graphing the function y equals 3 cosecant of 2x. Okay, so this is the solution. First is we need to graph the reciprocal of this function. So if we have cosecant, so this we're going to consider graphing y is equal to 3 sine of 2x. So from this given function, let us consider the amplitude, and we know that is 3, which is taken from the coefficient of sine. So we get its absolute value, so that is 3. And for the period, that is determined by the formula 2 pi over 2, or that is pi. And then divide, okay, then we draw the graph of y equals 3 sine of 2x. Ayan. Okay, so we have the asymptote. Ayan. Now, the green broken curve is actually the graph of this function. Then, determining the intersection of this curve with the x-axis, and these are the intersection. Why? Because at this intersection, okay, this is where those asymptotes will pass through. Okay? Okay, those vertical asymptotes. And then, since cosecant of x is 1 over sine of x, then the graph of y is equal to 3 cosecant 2x is shown in the right. Shown to the right. Okay, look. Yun. Okay? Yun. And you will notice that this curve will just approach this broken vertical line, but this curve can never touch the vertical lines or the vertical broken line. Okay, now the violet curve are the required function. So these are the now these curves, these parabolas represent the graph of this given function. Okay, next, how about graphing y is equal to 3 cosecant of 1 half x minus pi? Okay, prepare the Cartesian plane and labeling some coordinates along x and y axis. Okay, and then we draw some asymptotes. Okay, so of course we need to graph sine y equals 3 sine of 1 half x. So mother function at the same time. Then we determine the amplitude, which is 3, and the period is pi over 2 over 1 half, or 4 pi. And the phase shift is determined by this formula. Now for the fourth property, so we consider the phase shift given by the formula negative c over b, so that is negative of negative pi over 1 half. We simplify that, it's 2 pi. So it's positive, meaning the graph is moved 2 pi units to the right. Then, okay, we trace the graph of the mother function. Then the graph of y is equal to 3 sine of quantity 1 of x minus pi. Look at the blue graph. And then, okay, since cosecant of x is 1 over sine of x, then the graph of y is equal to 3 cosecant of quantity 1 of x minus pi is shown to the right. Okay. Ito. Okay? Yan. Okay? Okay, so we're done with the graph of cosecant function. So at this point, we are now going to consider the graph of secant function. And we have the properties together with the illustration. Now the properties of the graph of f of x equals secant of x are the following. First one is the period is equal to 2 pi. The asymptotes happen or occur at x coordinate, and these coordinates are determined by this formula. X is equal to pi over 2 plus n pi, where n represents an integer. Then the graph is symmetric with respect to the origin. The second function is an even function, meaning if x is replaced by negative x, the value of secant or will not change. It is so if it is positive, it is still positive, no matter how we replace it from x to negative x. If we're going to simplify, the result will not change its sign. Okay? Now, for the properties of the graph of f of x is equal to a secant of bx, meaning we are now considering the coefficients that are not just 1 but any other values. Okay, so this is the graph, and the properties are, okay, the first one is, okay, the period of the such function is given by the formula p is equal to the absolute value of 2 pi over b. Then the asymptotes of this function occur at coordinate x, determined by this formula. X is equal to quantity 2n minus 1 p all over 4, where n is again an integer. Okay? Then, let us consider some examples. Number 1, how do we graph the function y is equal to 2 secant of 8x? Okay. Now, first thing we need to do is to graph the reciprocal function of this given function. So that is your y is equal to 2 cosine of 8x. So from here, we determine the amplitude. So it's 2. And the period is 2 pi over 8 or pi over 4. Then we graph the function. Okay. Then we trace some asymptote. Okay. Then we trace the graph. Okay. And what else? Okay. For the required graph of y equals 2 secant of 8x. So we have these parabolas. Now, the yellow-green parabolas are the graphs of this given function. Okay. Actually, these graphs are the required graphs. Okay, or these parabolas is the required graphs. Okay. Yeah. Next, number 2. How about y is equal to 2 secant of quantity 8x minus 2 pi? Okay, so of course we need to trace the graph of its reciprocal function. So the amplitude is 2, the period is pi over 4, and the phase shift, okay, now for the phase shift, we have the formula negative c over b. So from this formula, we replace the value of c over b, so that is negative of negative. Okay, wait. So we have negative c over b, so that is actually negative of negative pi over 2 over 8. So we simplify this one, it will give us pi over 16. So it's positive, meaning the graph is moved by pi over 16 units to the right. Okay. Okay. Yun. Okay. So this is the graph. And then we have the parabola. We have the parabolas, and these parabolas represent the graph of this given function.